In this paper, we propose a multiscale hypergraph neural network for trajectory prediction with relational reasoning. The task aims to predict the future trajectories of multiple interactive agents. It has wide applications such as autonomous driving, sports, and surveillance. Modeling agent interaction is fundamental to precise and interpretable prediction. Previous methods have limitations from two aspects. First, only pairwise interactions are modeled. Second, only the interaction category are explicitly reasoned. However, in many scenarios, group-wise interaction is common, such as team cooperation, crowds of people, and a school of fish. Also, the strength of the interaction is common, like different magnitudes of forces. Thus, we propose our interaction modeling, which is novel in two aspects. First, we capture both pairwise and group-wise interactions. To achieve this, we learn a multiscale hypergraph and the different scale represent the different sizes of groups. Second, we infer interaction category and interaction strengths based on multiscale hypergraph. Integrated above, we propose GroupNet to obtain agent comprehensive interactive embeddings. The node in the multiscale hypergraph represents agent, and the hyperedge represents their interaction. GroupNet mainly consists of two parts. First is multiscale hypergraph topology inference. Second is multiscale hypergraph neural message passing. In the first part, we aim to learn a multiscale hypergraph. We model agents' affinity by attention operation and form hyperedges at different scales by solving submatrix of different sizes, which have a maximum sum of affinity scores. In the second part, there are two phases, node to hyperedge and hyperedge to node. In the node to hyperedge, we reason the interactions by proposing a three-element representation: strength, category, and a per-category function for relational reasoning. In the hyperedge to node phase, we update agent embedding by collecting relevant interactions. The node to hyperedge and hyperedge to node phases are iterated multiple times. We further add GroupNet as a core to a conditional VAE-based prediction system to predict future trajectories. GroupNet is used in the encoding process to obtain comprehensive agent embedding. We validate the relational reasoning ability of our method in physical simulation datasets. In this scenario, there are three interaction types: free, swing, and light bar. But in our model training, we do not know these underlying relations but only trajectories. In this setting, our GroupNet achieves the higher recognition accuracy under totally unsupervised circumstances compared to these baselines and achieves a close accuracy with the model having supervision labels, which means our GroupNet is capable of reasoning the interaction category. In this scenario, there are two charged particles with repulsive forces. A higher amount of charge will lead to a stronger repulsive force, thus a higher interaction strength. We plot the curve of our learned interaction strength and the electric charge. The curve shows a proportional relationship, which means GroupNet is capable of reasoning interaction strengths. We also conduct experiments in real-world datasets. We see that our method achieves state-of-the-art performance. Also, our GroupNet can be used in other previous frameworks, and it will lead to a performance gain. Here are some visualization results on the NBA dataset. Red and blue color represent players of two teams, and the green color represents the ball. Our method produces a more precise prediction in complex scenes. Here is a video visualization. When the video is dim, it means the prediction starts. Our method produces precise predictions. Thank you for your watching. Our code is open source on GitHub. Feel free to contact us if you have any questions.